Alright, so I'm going to start with what we did on, I think it was Friday. So for maths, basically, we just covered the basics of angles, and that's that note that you guys saw that I put on the PDF. So that's telling you about the different types of angles, how to name an angle, all those kinds of things. Remember, it's all basically from term 1. So if you guys are stuck, maybe just go back in your textbooks and just check. But it's pretty much all there. Alright, so basically what we're going to do now is I'm just going to recover everything on constructions. So the first thing is how to create a straight line. So we're going to take our ruler and we are going to measure, let's say, 7 meters because we want 5 meters. So we're going to put our compass point, this little point, on 0, and we're going to put our pencil point, that doesn't move, and we're going to put our pencil point on 7. So there's our 7 there. Okay. All we're going to do now is we're just going to take our compass and just draw a curve. That curve, remember, is called an arc. Okay. And then you should see there's like a little faint little piece where your point has created a little hole. So you're actually going to put a dot there. And then what you're going to do is you are going to connect. You don't need to measure now because you know that it's 7 centimeters. You've measured it with your compass. And you just connect that dot to the arc. And there is your straight line of 7 centimeters. Okay, so there's your straight line. The same thing with the triangles. Just a refresher, you've got like 4, I think it's 4 different triangles that you need to know. So we've got an equilateral triangle. Both sides are exactly the same. So what you should have done by now is you should have written the steps on how to do the constructions. And then what you do now from there is you basically just, draw them and you construct them. So I'm going to do that for you quickly. So that you can see just quickly how to do it. I should not need to explain it since the instructions are basically written down for you. Okay, so basically the that we're going to do, I'm going to do an equilateral triangle because that's pretty much the simplest one. Basically what you've got to do is you've got to measure out, let's say, let's make it 4 centimeters. Okay, so that means if it's an equilateral triangle, all the sides are going to be exactly the same. So that means I've got, so you just start and draw a line, so go from north. So you don't go at the edge of this ruler here, you actually start a bit in, you go from north, and you draw till 4. So I'm going to draw till 4. It's a bit off there. Okay, so till 4. And then what we're going to do is instead of now drawing a line there at 4 centimeters and a line here at 4 centimeters and they don't match and all that kind of stuff, you can try it out for yourself and see how it goes. But I'm going to tell you now, it's not that easy. You have to be very, very good at it. Then what you're going to do is you're actually going to take a compass and it's going to have the pre-measurement. All you're going to do, because it's 4 centimeters, remember we measured this as 4 centimeters already. So we're going to put our compass point over here and our pencil over here. So that means that that is 4 centimeters. All we're going to do now, actually change your triangle. So it can actually be at the bottom even. So let me just do it for you so that you can actually see. It doesn't always have to be on top. So you can actually just do your curve here. So there's your curve there. So my curve, I don't know if you can see, there's my curve that goes this way. So that's my arc. And then I'm going to do the same thing. My measurement is still exactly the same. I haven't changed it. All I do now is I just do a curve on this side as well. Okay. And then you're going to see that they're going to cross in between the middle here. So that part in the middle, we can name it something. So what happens usually is we're going to have to name this line. So let's name this A, B. And let's name this part, the intersection where they cut and they cross. Let's name that C. So what we're going to do now is, instead of having to measure everything again, all we do now is we take the point of A, we take our ruler, and we match it to A and to the dot over there. And then all we do is we just draw a line. So there's our one thing there, one side of our triangle, and the other side of our triangle. So that's now an equilateral triangle. So in order to show that, we're actually going to write that all those sides are equal. And how we're going to do that is by saying 4 centimeters. So if I've got a little line here, that means that wherever there's one line, that means that that's all going to be the same size. So that's 4 centimeters, 4 and 4. Okay, and that's triangle ABC. If you need to know how to write that, it's triangle ABC. Okay. Right, then we've got the isosceles next. So the isosceles is a bit more different. So all you're going to do now is, I'm going to draw it on top of here. The one thing that you need to keep in mind is that you can make your bottom, so this bottom line of your triangle, you can actually make that the longer line, and then from there you just make the smaller ones. So let's maybe say let's maybe make this 5. That's 5 centimeters. So I'm quickly going to write it down so that I don't forget. So that's A and B. And then what I'm going to do now is I'm going to measure on my ruler, because now remember the sides are going to be different lengths. So I'm then going to measure 0, and let's make it, instead of 5, let's make it 4. So I'm making this 4 centimeters. So I put the point on A, and I do my curve there, and my curve there. Alright, and then all I do now is I am then going to put a dot in the center where they've crossed, and that's going to be C. And then all I do now is I just connect from B to C. And then from A to C. Okay. Alright. And then the last thing that you need to do is you just need to write in that those two sides are the same, and that is 4 centimeters. Alright. One thing that you need to always keep in mind, this is just some extra information, which is actually pretty important for you. I'm going to use a different color, so I'm going to use purple. Here we go. So, if I'm busy looking at the equilateral triangle, something that's very important is the angles. Remember that if it's an equilateral triangle, all the sides are exactly the same. So that means that our angles will all be the same. So, if a triangle is supposed to add up to 180 degrees in total, and all the sides are the same. Oh, it looks blue on the picture. Oh well. Okay, this is actually purple. What I'm going to do now is, because they're all the same, I'm going to divide it by 3. So 180 divided by 3 is actually 60. So that means that this is 60 degrees, 60 degrees, and 60 degrees. So if you take your protractor, which is the little half circle, it looks something like this. And it's got a 0 here, and a 180. And or sometimes it's the opposite way around, doesn't really matter. And then there's a 90 on top here, things like that. So it should look like that. If you put that and match it to this angle here, you should get something around about 60 degrees. Alright, the same thing here. If you put in your protractor here, this angle over here at A will be similar, very, very, very similar. It might be like a few degrees off, but it's going to be very similar to each other. So that might be like, let me just guess. I'm going to guess now. So say, for instance, this is 45 degrees, and this is 45 degrees. Okay, so then these two angles are exactly the same because they're at the bottom of the two equal sides. Okay, that means that we're going to take 180 degrees and minus 2 45s. So what you can do is you can go 45 plus 45 gives me what? If you don't know, then you can just go 45 minus 45 minus 45. Same thing. Alright, and you're going to get your answer. Alright, and then you're going to put your answer in there so that you know how many degrees it's actually going to be. Okay, so we've got 90 degrees. So technically, this triangle now would actually not be called an isosceles anymore. Yes, it is an isosceles, but because of this 90 degrees, that means that these two lines are running perpendicular to each other. So AC is running at 90 degrees to CB. So that actually means that this will now be called a right-angled triangle. So it actually changes names sometimes, so you just need to keep that in mind. Alright. And then if we need to draw a right angle triangle straight from scratch, alright, without knowing that that's 90 degrees, then what we're going to do, pretty much the same steps in the beginning, so it's not too difficult. The one thing that you need to have with this one now is you need to have a protractor ready, or otherwise a set square. So I'm going to make this 6 centimeters. I don't know why, but I'm just going to make it 6 centimeters. And let's make it AB. Easy peasy. Okay, so now you can choose either side to be the 90 degree. Doesn't really matter. But if they are telling you specifically a certain side is 90 degrees, then you must obviously make it that side. But now they haven't told us, so now what I'm going to do is I'm just going to choose a point. I'm going to make, let's make B 90 degrees. Alright, so what we're going to do now is we're going to take our protractor. I don't seem to have one. So if you go and you take a protractor, you're going to make sure it's got this little like cross point. I don't know if I can show you. It's got like a cross, and that's called your origin, or sometimes in some of these protractors it's got a circle in the middle. So it does that, and then it's got the curve. Well, I'm doing it wrong now, but whatever. Okay, so we've got the curve, and then it's got the naught here and the 180, or the 180 and the naught. It should actually be this, to be honest. And then naught and 180. No, other way around. 180 and naught. Okay, so what happens now is you actually now going to put that origin on B, and you're going to match this line here to this line. Okay, so I don't have a protractor, unfortunately. I don't actually know where it went. So you can't do this in the exam. You actually need to have one, or otherwise you need to have a set square. A set square is basically a triangle. Okay, and it's got a small little 90 degree there, and then sometimes it's got an opening over here. Pretty much it looks something like that. Okay, it should be in your math set. Yeah, I don't really have one. I'll find one at some point. And then you're going to put that set square on B, and that's also going to show you 90 degrees. And then what you do is when you hit the 90 degrees, which is on top here, alright, all you're going to do is then you're just going to put the dot at the 90 degrees on your protractor. Where your protractor ends, you just put a dot, okay, so that you know that that's the 90. So let's pretend that I've got my protractor, I've put it on, and I'm going to put my 90 degrees here. So that's where my 90 dot is. So I'm just saying that that's my 90 degrees dot. Alright, you don't have to write the 90 degrees, I'm just saying it for you so that you know. And then what we're going to do is we don't do anything else after that, because that's our 90 degrees done. So we know that it's perpendicular, but we need to still measure the length of it. Alright, so now what we're going to do is, so we've got 6, so let's make it 4 again. Okay, so we're going to make it 4 centimeters, so put it on naught and make it 4 centimeters long. Alright, I don't know why I have 4 in my head all the time, but anyways, so we've got that, and then we're making our 4, so we put the point over here, so BC is going to be 4 centimeters. So what we're going to do is, here is C, alright, and then we're just going to take our ruler and we are going to connect it. So match B up with that 90-degree dot, and all you do is you can either go from the curve down to B, or you can go from B up to the curve, and that is your point C. Okay, so the 90 degrees, that's just telling us that it's at 90, so that's just telling us that part. Alright, the rest is telling us how long it is. That curve is telling us how long it is. Then all you do now is you actually don't need to measure the rest of it. All you do now is you just go and you connect it. And that is that. It's not that difficult. Alright, and there's my triangle. Last thing that I just need to write in is that this is 4 centimeters. Something else that you just might need to know, especially if you go to when you go to high school, you will learn about this type of triangle. I don't know if you have had any brothers or sisters or cousins or anything that have actually gone to high school and they start talking about Pythagoras. It's a theory that somebody has written about the right angle triangle. So basically what happens is that these two sides create this side. So this side is actually going to be the longest line. So out of everything, this will be longer. So it will be bigger than 6 and 4. So let's make it 7 centimeters. Okay, just a guess. So if you measure it, it should actually become a little bit bigger at least than both of them. So I'll actually measure it for you and I'll tell you. It is 7.5 centimeters. Okay, so that's one way that you can do that. Last section, of course, is the rectangles and squares. Okay, and then what I'm going to do is I will make another video on all the properties and things that I need you guys to know about the triangles and all that kind of stuff. So this is just constructing them, this is just drawing them. So we've got all the quadrilaterals. So just so that you remember, quads or quadrilaterals is basically quadrilaterals. They have 4 sides. Remember, a triangle, tri for tricycle, has 3 sides, and quadrilaterals have 4. Alright, so we're just basically going to cover a square and a rectangle. One thing that I've also mentioned before is that it doesn't matter if you do it skew. So what I'm going to do is I'm actually going to draw you a skew one today, just so that you know it doesn't matter if this is skew, as long as the actual shape measurements are not skew. Okay, so if you don't understand, maybe just keep watching and then maybe you'll see what I mean. Okay, so I'm going to make this 5 centimeters long. So I'm just going to draw a line of 5 centimeters. Okay, so that's my 5 centimeters. And then what I'm going to do now is, it's actually pretty simple. So you're going to do the same thing with your protractor over here, alright, or your set square, because it needs to be at 90 degrees. Squares are at 90 degrees, and the same with the rectangles. Alright, so you're going to then focus on that, and we're going to I'm going to have to guess now because I don't have one. So we're going to now say that this is now 90 degrees. So let's say that that's 90. So we're doing it at this point here, and we're going to make this point here as well. So we're going to put our protractor there, make sure the cross is there, so the origin is there, and then we're going to put a dot at 90 degrees. Okay, it might look a bit skew because I don't have an actual protractor or a set square, but we'll see. Alright, so now because we have a square, remember all the sides are the same, so we can actually just use the same length here. Because if we're going to look for 5 all over, we actually got 5 already. So we're just going to do a curve, and we're going to do the same thing here, make a curve, so that's our 5. Alright, and then we're going to do the matching thing. Alright, so yeah, I did this very skew, but anyways, just pretend that I had it at 90 degrees. Alright, so I'm going to connect. So there's my dot telling me that it's at 90 degrees, and then here is my 5 centimeter curve. Okay, and the same thing here. There's my dot telling me it's at 90, so that's the 90 part. And here is my curve telling me it's 5. Okay, and then all we do now is we just connect the two tops together. Cool, there's our square. So that means that all those sides are exactly the same. Right, so it doesn't matter if your shape is skew. It can be straight as well if you want to, but as long as it's at 90 degrees. And just remember that every side is at 90 degrees. Last one is the rectangle. Pretty much exactly the same. So I'll make this one straight for you. So I'm going to make it, let's make it 7. So let's make it 7, let's make it 8 centimeters. Okay, so I'm making this 8 centimeters. Alright, and I'm going to do exactly the same thing. I'm going to pretend that I have my protractor, put in the origin here, make sure that the line with the naught and the 180 is matching this line, and that the origin is here. Okay, then you're going to measure out the 90 degrees, or you're going to put it on your set square, and then you're just going to dot where you think, or where you see the 90 degrees. Okay, the same thing here. We're going to see the 90 degrees here. Okay, then, now because it's a rectangle, it can't be 8 centimeters as well. So what we're going to have to do now is we're going to have to measure the other side. So the other side, let's make it, usually what will happen is we will give you the measurements, right? So it's not like you will have to guess the measurements. Okay, so what we can do now is we can change the measurement. So we can either make it, we can make it 5 or we can make it 3. Let's make it 3. Let's just make it small for today. Okay, so let's pretend that this is now 3 centimeters. Alright, so we've got our point on there, and we're going to make our arc, and the same thing here, going to make our arc. Right, sorted. Got 2 little hills, and then all we're going to do now is do the same thing. We're going to connect. Alright, so we're going to go from here, connect it to the arc, and that is telling us that it's at 90. Same thing on this side. Alright, we're going to have our point, wherever I put it, I think it's just that one. Okay, we're going to have our point to show us that it's 90. We're going to connect it from the arc to there, and there's our 90. Alright, and then what we do now is we just connect the 2 lines together at the arcs. Alright, there we go. So that means that if this is 8, the top one is also 8. So you can actually measure it, it should be the same. So there we go, as you can see it is 8 centimeters. Alright, and then this is then 3. You just need to tell me that it's 3. Alright, and then you just show that those are both the same. And there is my right angle triangle. Okay, it is not a square and it is not a rectangle if it does not have the 90 degrees. Otherwise it is a rhombus or a parallelogram. Alright, otherwise that is pretty much that for today. I am going to make another video basically explaining the different types of quadrilaterals for you. And yeah. Also, if you need to know how to draw a square, a circle, just to show you for reference. Okay, so you've got a circle. Okay, so what's going to happen now is you're going to take a compass. You're actually going to now have the radius. So let's say the radius is 4 centimeters again. Let's make it 4. So we've got the radius of 4. That means that one part of it is 4. Okay, and then it's going to make a big circle. So make enough space because it's going to go all the way. Oops. Around. Okay, I did a bit funny, but anyways, because I'm using the wrong place. So there's your circle, goes all the way around. Something that you just need to keep in mind is where your point of your compass was. You just need to put a dot there. That's called your center of your circle. And then you're going to just connect it to either side. You can maybe make it here. So that's your radius. Okay. Doesn't really matter where it goes. Anywhere from the center of the circle to the outside is called your radius. And then that we label as 4 centimeters. Alright, and that is that for today. Otherwise, I will send another video soon, and then hopefully this makes enough sense for you.